So we're going to be looking at the study guide for the scientific notation quiz for 8th grade. So let's get started. The first three questions here are on changing numbers into scientific notation. And if you remember, scientific notation is that form where we have a number a times 10 to some exponent, where this number a here is between 1 and 9. So it's like 1 point something all the way up to 9 point something. You can't have 10 point something and you can't have 0 point something. And the exponent here, n, is between, well, it's just a number that's not a decimal or a fraction, so we call that an integer. And as long as it's not a decimal or fraction, then we're good. And that n there counts the number of jumps we move the decimal point to get into our scientific notation. So for example, number 1 here, what we want to do is keep jumping the decimal until we have exactly one non-zero number in front of it. So in this case here, if we start with our decimal point at the very end and we jump our decimal, we go 1, 2, 3, 4, 5, 6, 7, 8. So it takes us 8 jumps to get to exactly one number in front of the decimal. Any less, then we'd have more numbers in front of the decimal than we need. So right now we'd write this as 1.1025. Again, we don't need the extra zeros at the end. That's the whole point of doing this. And it would be times 10 to however many times we jumped, which in this case is 8. And again, the reason this is positive because this number started as a big number, which is basically anything more than 1 in our case. So because this number started as something more than 1, our exponent is going to be positive rather than negative. And that would be all we do for that one. So again, the exponent counts the number of jumps, and it's positive if the number of jumps is from a number that's big, and be negative if the number was small. So number 2 here, we start with our decimal point, which is given to us right here, and we jump 1, 2, 3, 4, 5 times. So it'd be 6.7 times 10 to the 5, and because this number started out small, it'd be a negative 5 instead of a positive 5. Because we're going from a small number to begin with, which is basically anything that's 0 point something. So if it starts with 0 point something, then it's going to be a negative number. If it's bigger than 0 point something, it'd be a positive number. For number 3, our decimal point's right in the middle there, so all we need to do is jump 1, 2. So you'd have 1.0468, and then it'd be times 10 to the second. And again, this still counts as a big number because it's basically more than 0 point something. If it was 0 point something, then this would be a negative exponent, but it's a positive exponent because it's a number that's more than 0 point something. And so again, you start wherever your decimal point is located. In this one and in this one, the decimal point was given to us, and then in number 1, we just assume it's behind the number. The other 2 questions are about going in reverse. So for number 5, we want to go from scientific notation to standard. Remember, this type of number, this one, and this one, those are all standard numbers, and then scientific is when it's in this form here. So what this says here is you start with 1.02, and this says 5 jumps. So we're going to jump the decimal point 5 times, and if it's a positive exponent, then you're going to jump to the right, and if it's a negative exponent, whoops, sorry about that. If it's a negative exponent, let me get that out there, then you're going to jump to the left. So in this case, it's a positive 5, so I'm going to take my exponent and jump it right 5 times. 1, 2, 3, 4, 5. And I get 1, 0, 2, 0, 0, 0. Remember, all these empty spots here get filled in with the 0, and that would be the original number. And again, it makes sense because this is a big number, so my exponent's positive, which is good. If this was a small number, then that wouldn't match up with the exponent. In this case, we do 3.65, and it's to a negative 6. So that means we're going to jump the exponent to the left 6 times. So 1, 2, 3, 4, 5, 6. And again, all these empty spots here are going to be filled in with a 0. So it'd be 0.00000, and then 365. And if you want to, you can put a 0 up front too, but that would be your final answer. And again, it's a decent check here because this number is a small number, the exponent's negative, so that matches up there. So again, the first few questions are just about going to scientific notation or going to standard notation. And it's just a matter of, again, jumping the decimal point either left or right. That's all there really is to it. So just make sure you know what direction to jump and we should be okay. The next four deal with actually operating in scientific notation. So the goal here is to solve these problems without having to write out all the zeros. So you don't want to change this into 840000. You want to keep it like this and operate with it in scientific notation. And the way you do that for division and multiplication is pretty simple. You just operate with the decimal numbers, then operate with the scientific end of it. So for example, in this case, what I would do is I'd first focus on these numbers here. I'd do 8.4 divided by 4.5, and I get my answer there. So I just take them separately, and I get about 1.86 repeating. So I put a little bar over the 6 because it's repeating. And then I would take these numbers and divide those. So 10 to the 5th divided by 10 to the negative 3rd. And remember, when you're dividing bases, what you do is you take the base and you take the two exponents and you subtract the exponents. So dividing bases means you're actually going to subtract the exponents. And in this case, we have a double negative right here. So that's going to make one big positive. So this is going to be 10 to the 8th. And so how I'd write this would be the decimal number first times 10 to the 8th. So all you really do is, again, you just work with the decimal numbers by themselves, you work with the 10 numbers by themselves, and just put them together at the end. So it's a really just two-part sequence there. And the same goes for multiplication. So I would take these two numbers and multiply them separately. So, whoops, let me try again. So 1.02 times 3.06. And so you'd work with that on their own. So you take 1.02 times 3.06, and you get 3.1212. And then you take the 10 numbers and multiply them together. So we'd have 10 to the 7th times 10 to the negative 3rd. And remember that when you're multiplying bases with different exponents, what you do is you add the exponents together. So this would be 10 to the 4th. So again, multiplying bases means you add the exponents. So my answer is just going to be 3.1212 times 10 to the 4th. And again, all you do is you work with them separately. Oops, let me try that again. There we go. You work with them separately and then just put them together at the end. So the decimal numbers do their thing, the 10 numbers do their thing, and then you just slap them together. All right. On the next side, addition and subtraction is a little bit more difficult. What you have to do for addition and subtraction is you have to make sure that both the 10 numbers have the exact same exponent. So right here, this is 10 to the 10th, this is 10 to the 8th. We can't really add these numbers until both these exponents are the same. And so you can either bring the 10 down to an 8, or you can bring the 8 up to a 10. It really doesn't matter either way. Let's just go ahead and bring the 8 up to a 10. So the way you do that is you take your decimal point, and it's kind of like going into scientific notation. If you want to make the number, if you want to make the exponent go up, so we'll put it here. If you want to make the exponent go up, what you do is you move the decimal point to the left. If you want to make the exponent go down, what you do is you move the exponent to the right. So I want to make this 8 go up to a 10. So I'm going to move my exponent, or my decimal, up twice, 1, 2. So it's going to be 0.013 times 10 to the 10th. And then now, once I have this set in parentheses here, and I want to add it to this, all you need to do now is kind of like with multiplication division. You just add the decimal numbers, so 2.5 plus 0.013. If we do some quick addition there, that'd be 2.513. And then your answer is just that decimal number, 2.513 times 10 to the 10th, which is what the common 10 numbers are now. So, and again, we'll do the same thing for subtraction here in a moment, but what you have to do is make sure your exponents are equal between all the terms, and then you can just add the decimal numbers and bring your 10 number down. And again, you could have brought the 10 down to an 8 as well. It wouldn't have mattered, but usually it's just easier to bring the small number up rather than the big number down. It saves you some work at the end. But that's all there is to it that way. So it's a little bit more complicated because you have to get the 10 number, you have to get the exponents to agree. But other than that, it's just add the decimal numbers and then slap the 10 at the end. This one here is actually already set up for us. We have 10 to the 12th, 10 to the 12th. So these are already agreeing. So my answer is going to be something times 10 to the 12th. I mean, I know that already. So that's going to agree there. So now all I need to do is 5.6 minus 4.5. So 5.6 minus 4.5. And so if we do that real quick, 5.6 minus 4.5 will give us 1.1. And then that means I'm done. So if they already agree, 10 to the 12th, 10 to the 12th, then you're already good. The only time you have an issue is when they don't agree and you have to make them agree like we did in the first one. But if they're already agreeing with each other, then you can just subtract the decimal numbers and you're done. So addition and subtraction is a little bit more complicated, but again, just remember that anytime you want to change the exponent, if you want to make it go up, just move your decimal point to the left. If you want to make the exponent go down, just move it to the right. And then you can adjust the exponent on the scientific number however you want. The last three questions are just basic exponent rules. So there's no times 10 or anything. It's just how do you operate with exponents given different operations. And so again, the rule of thumb here is that when you divide, that means you subtract the exponents. When you multiply, that means you're going to add the exponents. And then when you take exponents to different powers, so we'll say if you take a power to a power, then you multiply the exponents. Those are the three basic rules. If you know those three rules, you can do any of these. So number 13 is the first one. Division means subtraction. So that means that if I take these two here, z to the third times z to the second is going to be z to the 3 minus 2, which is just going to be z to the first. I do the same thing with the w's. So w to the fifth divided by w to the fourth is w to the 5 minus 4, which is just w to the first. You could have also written it as just zw. That's the same thing as well, because you don't have to write the 1 there if you don't want to. But both these answers would be correct. Same for 14. So 14, we're going to leave this as it is for right now, 3a to the third. And in this case, we have a to the second and to the fifth. So we have two exponents back to back. And that's what this rule is for. That means that you're going to multiply them together when you see two exponents back to back. So this is going to be 2 times 5, which is 10. And so we'll get times a to the 10th. Now, in this case, this 3 can't do anything, so we're just going to leave it as a 3. But here we have an a to the third times an a to the 10th. Well, again, if you're multiplying bases, you have to add the exponents. So this would be a to the 13th, which is just 3 plus 10. And that's how we get our answer for that one. So this one required you to do two rules back to back. First, it was the power rule to get our exponents combined, and then it was the multiplication rule to get our final exponent on the variable. And the last one here has another special sub rule to it. So the other sub rule is that anything to the 0 power is automatically 1. So this h right here is automatically 1. So you can essentially forget about it because 1 times anything is just itself, so it's not going to really bother anything. This is another sub rule here, is that a negative exponent. So let's combine these first and then we'll talk about it. So h to the negative 13th times h to the 5th. Well, again, that's a multiplication rule. So this is going to be h to the negative 13th plus 5, which is h to the 8th. And of course, it's going to be a negative 8 because 13 is bigger than 5. Now, the rules here say use only positive exponents. And obviously, negative 8 is not a positive exponent. So how do we make it positive? Well, the rule is that if you have any number, we'll call it a, any number to any negative exponent, you can make it positive by just switching the position, usually putting it on bottom, although the reverse is also true. So this h to the negative 8 can be written as 1 over h to the positive 8. and then that would be how I leave my answer. So putting the negative exponent on the bottom actually makes it positive because if it's on the bottom, it's already assumed to be negative in a sense. So basically this means negative 8 or h to the negative 8 over 1. So if I just flip it or reciprocate it, then it becomes the positive version. Um, and so that's how you change a negative exponent to a positive is you switch the position of the value. So as a sub-example here, if I had something like 1 over a to the negative 11th, and I wanted to write that as a positive exponent, I would switch it around and do a to the positive 11th over 1, or even just a to the positive 11th. All three of these are the same. So these all three mean the same thing. It's just that these two have positive exponents, which is generally more preferred than a negative exponent. So that's the rundown of the scientific questions. Again, mainly the scientific notation stuff here is going to be the more difficult ones, but you do need to remember your exponent rules in order to do the last few questions. Hope you enjoyed the video. Have a good day.